Alright, in this sketch we're going to use the Dallas one-wire temperature chip, and Dallas is now Maxim integrated. And make sure you follow the instructions on installing the one-wire library before you try and compile this. It will fail if you do not install the library. I'll show you that here, the sketch in the libraries, and you can see I have it down here. And that's what you should see when you're all finished. You should see the one-wire library added in here. Okay, so we've got the library added. We'll come through here. We do the include file for the one-wire. We do some setup, tell it which pin it's connected. We're on pin 10. And I create a little flag here, display flag. And I did that so that we only display the connection data once, not every time we go out and do a read. So let's move on here. So here's the loop, and to start off, define some variables, and we're going to go out and look for the chip, and we search the addresses, and if it cannot find it out there, it'll reset it and return back to the Arduino handler. If it does find something, it'll take the address and check the CRC. CRC is a way of checking for errors, an error prevention. It won't correct a bad bit, but if you happen to have a corrupted bit, it'll let you know that your data is corrupt and not to use it. So in the begin, the display flag is 0. We're going to start off and we're going to print out where we found it. We'll print out the 8 data registers, and this is a for loop, which is a new construct, and it sets an integer variable I from 0 until I is less than 8, and every time you go through the loop, increment I by 1. So in this case, I will be 0, 1, 2, 3, 4, 5, 6, and 7, and then it will leave the loop down here. And as that, what we're using that I for is to index into what's called an array variable of bytes, and it'll get the 8 data registers from the chip and print them out with spaces. And here it's going to go and check address 0 and look for what type of device it is, and it'll print that out also. Now I set the display flag equal to 1, so next time we come through this loop, it won't be equal to 0 anymore, and so this code will not execute. That only executes once. Right? We'll go out and reset it. We'll select it at that address, and we'll start a conversion by giving it a start conversion command. We'll wait. We're going to delay a second. And then we go out and select it again and tell it we want to read from it, and giving it commands. And now we're going to print our results out, but we're going to extract the data from the temperature chip, and we'll start displaying it, and we're going to print it out as hex values. That's what this format here means. And we'll print the CRC so we can see what that is. So we're getting our 9 data values plus the CRC. Now that we've got all our data from the chip, we can get to work and convert it and start working with it. In this case, we have 2 bytes to work with, low byte and high byte. And we're going to create a 16-bit value by first shifting the high byte over by 8 bits and adding the low byte to it. So now we'll get a 16-bit value all set up there. We'll test the sign bit, and if it's negative, we'll handle the 2 complement conversion. If it's not negative, we're going to then turn around and multiply that value by 0.0625. And that will give us a whole portion and a fractional portion. And we're done. No conversion, I say no conversion, no curve fitting, and no calibration. We're taking our data, it's already factory calibrated, and now we get to print it. If the sign bit was set up above, we'll print out that negative sign, and then the whole portion, print out a decimal point, and then the fractional portion. And that's it. Pretty straightforward, utilizing the one-wire serial routines. And as you can see here, we're not doing an LCD print anymore. We're doing a serial print. And that will go out to the display. So now if I come up here and I upload that, we'll go compile this. Now that that's done uploading, I go to Tools, Serial Monitor, and there we go. And what you can see here is in every loop we're displaying all 9 of those data values plus the CRC and then the calculated temperature. So if you're looking for something over on your LCD display, it's going to be blank. There's nothing wrong with the LCD. We're not sending anything out there. We're using this serial monitor here. Okay, when I'm all done, close it up, come on back here, and you can go back to your coding.